So now let us start. Love keep heading. Cause of chemical combination. So if you notice it here, the question is why the metals or non-metals will react. What is the purpose behind for the reaction? Why they are undergoing the chemical reaction to form the new compounds. So this is what is all about the concept. So if you all notice it here, we know that the chemical substances take part in the chemical reaction, whatever it is. There may be the atoms of elements or molecules of compounds or some other XYZ. So what is the purpose they are involving in the chemical reaction is the only purpose is to acquire the what? Everybody? To acquire stability. So that is what is the purpose and the main thing, and minimum energy stays means they should not lose the energy for formation of like instability, we can say that. So when the elements or the atoms of the elements, if they do not have stability, so always they will lose more energy. So that is what. So every chemical substances, whatever the things involving, they wants to react with some other thing. They wants to form a new compound with some other element only because of to acquire the stability and as well as to minimize the loss of energy. That is what energy state. So generally, if you take part in any chemical reaction, so what is the main reason is to involve is to complete the octet rule. You might be studied in ninth class. What is the octet rule, everybody? To complete their octet rule. That is the main purpose actually to undergo the chemical reaction. So whatever the element, whatever the atom is undergoing the chemical reaction, the main purpose is to complete the what? Everybody? To complete their octet. Okay, guys? So what is the reason octet? What do you mean by octet rule? Anybody can tell? Yes, please. What do you mean by octet? Octet rule. தெரியாதா தெரியுமா? Please respond. What do you mean by octet rule? Hello, people are there? Anybody? Hello, dumb fellows only, yeah? Okay, Vijay, thank you. So if you are, what do you mean by octet rule? Having the 8 electrons, in which cell?
Balance.
That is what we used to call as octet rule. Remember, if any kind of atom, if it contains 8 electrons in its valence shell, it will acquire stability. It will become stable in nature, means unreactive. So to acquire this only, to complete their octet, in order to acquire nearest noble gas. This is the most important point. Nearest gas electronic configuration. So this electronic configuration is the main thing which you used to study in 9th class. The same thing again we will study in 10th class also. So all of you observe, whatever the element is undergoing the chemical reaction, the purpose is to obtain the octet in order to acquire the nearest inert gas electronic configuration. So what do you mean by nearest noble gas actually? Nearest noble gas, here I forgot, acquire nearest noble gas. So noble gas means what? Even yesterday I have shown you, day before yesterday also. Noble gases are also called as unreactive
Unit gas.
gases, okay, stable gases, okay. So these gases, to acquire the nearest electronic configuration of noble gases, they will start doing it. So what does it mean? So if you observe here, they want to have 8 electrons in their valence shell. That is what stability. They must, every atom wants, they must have, they want to be how many electrons? Yes, please. They want to have 8 electrons in valence shell. So then only they will acquire the stability. So if they want to acquire the 8 electrons in its valence shell, the one way is either by donating electrons, and another way is by what? Everybody? Either by donating or by accepting electrons. Understanding? So by either donating the electrons or by accepting the electrons, or one more thing is there. Accepting, one more thing is, what is that? Non-metals. By sharing of electrons. So any 3 ways, either by donating or accepting or sharing of electrons, they will obtain 8 electrons in their valence shell. So that is the rule we used to call as, what is the rule we used to call, everybody? Octet rule. Okay.
Octet rule.
So whenever these, you can take any kind of elements, if they want to acquire their 8 electrons in their valence shell, so either by donating or by accepting or by sharing of electrons, they will acquire the stability. They will acquire the 8 electrons in their valence shell. That is the rule we used to call as octet rule. Please learn it. So, okay. So now if it comes to the, when metals, all of you observe very carefully. When metals combine with the non-metals, when metals combine with the non-metals, okay, so they undergoes transfer of electrons. When metals combine with the non-metals, be very careful. So what will happen? Electron transfer will take place. Electrons are transferred from where to where, guys? Anybody? Electrons are transferred from where to where? Electrons are transferred from, respond Ra, metals to
non-metals.
So means metals will donate the electrons, metals will donate electrons, and non-metals will, what they will do? Receive electrons or accept the electrons. Okay, so that is what you have to remember. Suppose if we take 2 non-metals, when 2 non-metals will combine together, what will happen, guys? Yesterday I have told you what is a bond will form. If the 2 non-metals will combine, remember this is only called as ionic bond. This is called as ionic bond. What was to call? Metal will donate the electron, non-metal will accept the electron. That is called as ionic bond. When 2 non-metals will combine together, what will take place, guys? No donating, no accepting. Only one thing. What is that?
Sharing of electrons.
Combine together. So remember all of you, then sharing of electrons will take place. So this compounds only called as what? Anybody? Sharing of electrons.
Covalent compounds.
Covalent compounds. Electrons takes place. So because we are going to study properties of ionic compounds, properties of covalent compounds and all. So please have a glance and everything learn. So keep in mind, when metal will donate the electrons, non-metal will receive the electrons or accept the electron. That compound is called as what? Ionic compounds, and bonds we used to called as ionic bonds. Next, if 2 non-metals will combine together, then sharing of electrons will take place. This is what we used to called as, everybody, we used to called as what? Covalent bond. Understand? So after sharing or after transfer of electron, whatever it is, if you observe, the atoms, they will held together due to the force of attraction, whatever it is, either sharing or by donating and receiving. So that is what we used to call the force of attraction, which will hold them together, which will make them together. That is only called as bond. What we used to call, everybody? Bond, or we can say chemical bond. And these atoms are called bonded atoms. After formation of chemical compound, the atoms which are together, we used to called as what, everybody? We used to called as bonded atoms. Why they are together? Because of force of attraction. Okay. Now, if you observe everything carefully, so whatever you take it, metal or non-metal or noble gases, whatever it is, see who will decides the behavior. Suppose you take a boy or a girl or some other. If I take any particular person, who will decides the behavior? So that is what we used to call as electronic configuration. So who is the supreme authority to decide the behavior of an element? Everybody? Yes, please. Please respond. Electronic configuration. Keep in mind, the chemical reactivity of any element depends on its electronic configuration, depends on its valency, depends on number of valence electrons. Three reasons I'm giving you. All three reasons will speak about the same thing. So please write that point. Chemical behavior, very important point. So who will decide the chemical behavior of element? Everybody? Yes, please. Chemical behavior of an element depends upon what? All of you?
Electronic
Electronic
configuration.
configuration.
Electronic configuration. Be very careful. Electronic configuration only will decide the chemical behavior of any kind of element. Electronic configuration. Write it. Electronic configuration. What does it mean? This electronic configuration means, all of you remember, I will say you, that is what? Its position in periodic table. That is what is only called as periodic table. So that is only we can say electronic configuration. So you can say that any chemical reactivity, the chemical reactivity, either it is reacting very faster or it is reacting very slower or it is reacting some other understanding. Either it is donating electrons or it is receiving electrons, whatever it is. The chemical reactivity of any element is depends upon, understanding, depends on its valency. Valency means what? How many electrons it can donate or how many electrons it can receive. That is what 9th class, what is the definition you studied valency means? Anybody? Combining capacity of an element. Am I right, everybody? Yes, please. Combining
Yes, sir.
capacity of an element is called valency, or we can say number of valence electrons. Number of valence electrons. So that will decides the element behavior. So those elements which have incomplete valence cell are reactive in nature. Those elements which have complete valence cell, they are said to be unreactive. Keep it in mind, incomplete valence cell, they are reactive or unreactive, guys? They are reactive in nature. Complete valence cell, what they are? Speak, everybody. Complete valence cell, they are unreactive in nature. Okay, so that is what. So what is the rule? We'll verify, everybody. What is the rule we'll verify? Octet rule. Keep it in mind. Octet rule is the one which will decide either the element is reactive or unreactive. Okay, guys, all of you? Yes, please. So now let us go to the periodic table. So as I said, chemical behavior of an element depends upon the electronic configuration. Means in the what? Its position in periodic table. So that's why periodic table is deleted from your class 10th, but without periodic table, no chapter has been moving forward. So this is what we used to call as periodic table. Am I right, everybody? So I think many times I'm showing the same thing. Clear, everybody? So if you notice it here, so in our periodic table, basically, if you observe, we have 18 groups. How many groups we have? 18 groups and as well as 7 periods. Okay. So you can check it here. This is first one, second one, third one, fourth one, fifth one, sixth one, and seventh one. 7 periods we have. Okay. And 18 groups we have. So group number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and this is what? 18. Clear, everybody? So 7 rows and as well as 18 groups. Understanding, Amma? Now, this periodic table, all of you remember, here the gaps only, if you notice it here, 89 after 104 is coming. This is what we used to call as lanthanoids. And here if you notice, sorry, lanthanoids 57 to 72, 89 to 104 actinoids. So actinoids and as well as lanthanoids. So that is what it will come. They are having similar chemical properties. So that's all it is. The things which is mentioned below. Of course, it is the deleted for you. It's not at all worry about it. Next chapter actually, after carbons compounds, periodic classification. It's entirely deleted, but we must have an idea. So remember all of you, first column we used to call it as, what is the name of that? First column, alkaline, alkali metals. I have taught you or not? The first column, lithium, sodium, potassium, rubidium, cesium, and francium. We used to call it as what? Alkali. Respond, alkali metals. Understanding, Amma? So alkali metals, these are called as alkali metals. Now, can you tell me what is the electronic configuration of sodium? Let me take sodium. Sodium is very, very important for us. So let me take sodium. Can you tell me what is the sodium electronic configuration? Atomic number.
2,8,1.
Atomic number is 11. So that what is the electronic configuration?
2,8,1.
2,8,1. So KLM. So this is the valence shell. So valence shell, how many electrons are there? Valence shell,
One
One
one.
electron.
That is why they are very reactive, highly reactive. So they wants to become stable. So they are always ready to donate 1 electron. How many electrons they will donate? Alkali metals. Alkali metals, they will donate 1 electron. So
1
that's why
electron.
they are very reactive, highly reactive in nature. So once 1 electron is removed, so sodium will turns into sodium atom, sorry, sodium ion. So then what is the electronic configuration? 2,8.
2,8.
Valence shell having 8 electrons. So it's become stable or not? Everybody, it's become stable in nature. Same way if you take 17th group, fluorine, chlorine. Let me take chlorine. So we are all familiar with the chlorine. Chlorine atomic number is what? Here you check it.
17.
17. So what is the electronic configuration? Girls, electronic configuration of chlorine. 2, 8, 7. So K, L, M. So valence electrons. How many valence electrons? Everybody? Valence electrons.
7
7.
electrons.
So to become stable in nature, how many electrons is needed? To become stable,
1 electron.
1 electron is needed. That is why these are called as, I told you, what is the name of this one? All of you. Halogens.
Halogen.
So they are stable in nature. So that to acquire the stability, they need 1 electron. So what is the purpose? Why they will acquire the stability? Anybody? To attain something I said before, starting you see that. To attain nearest noble gas electronic configuration. Am I written or not, Harish? Everybody written? So what is the reason,
Yes,
guys?
sir.
The chemical reaction to complete their what? The chemical reaction will take place to complete their octet rule. Understanding? And attains what? In order to acquire in order to acquire what? What you have written, check it. Nearest which
Noble
gas
gas.
electronic configuration? Nearest noble gas electronic configuration. So what do you mean by this? You will understand it. All of you see, noble gases except helium. So helium, except helium, remaining all the noble gases, valence cell, how many electrons will be? Valence cell, everybody, 8 electrons. Understanding? That is why neon, argon, krypton, xenon, radon, every element, they are having 8 electrons in valence cell. They are only called as what? Everybody, noble gases. Understanding? Unreactive gases, stable gases. Now, helium is also called as noble gas. Why, guys? Anybody can tell? Helium is also called as noble gas. Of course, helium is having only single shell. How many cells it has? Everybody, only single cell.
One cell.
That single cell is K cell. Keep in mind, any element having only one shell, that cell name is what? You speak only will remember. That cell name is what? K shell.
K.
Then, if it has 2 electrons in its valence shell, that K shell itself is the valence shell. Note it, my point. If any element having only one shell, that cell name is K shell, and if it has 2 electrons, it is also called as noble gas. Clear, everybody? So it will become stable in nature because it does not have more than one shell. It has only how many cells? Everybody. It has only how many cells, guys? One cell. And the K shell maximum capacity is how much? Maximum capacity is how much? Only 2 electrons. Understanding? So only 2 electrons. That is why, except helium, remaining all the noble gases having how many electrons, guys? Remaining all the matter, how many electrons? Please respond. 8 electrons in their valence shell. You can check it. How many electrons? All of you? Yes, please. 8 electrons in it. Only helium. Helium, how many cells are there? Check it. Only one cell is there. What is the cell name? What is the cell name it is?
K shell.
K shell.
K shell.
So if any element is having the number of electrons present in valence cell of helium is only 2. So it's already completed. So K shell cannot take more than 2. So it's become stable in nature. Do you understand, everybody? Please respond, all of you. If we take argon, how many electrons? You can check it. Again, 8 electrons in its valence cell. If you take krypton, again 8 electrons in its valence cell. If you take xenon, again 8 electrons in its valence cell. If you take radon, again 8 electrons in its valence cell. So that's what, they are all noble gases. So if any kind of element, it will acquire 8 electrons in its valence cell, it will become stable in nature. Do you understand, guys? Please speak. All of you? Understand?
Yes, sir.
Only when they will become stable, everybody, 8 electrons in valence cell impart stability to atom, where 2 electrons in valence cell impart stability. When? Anybody can tell? 2 electrons in valence cell, but it needs stability. When? Only the outermost shell is the what cell? Outermost
K
cell
shell.
is the what cell? K cell. Okay. That is possible only for the which element? Everybody? Helium. Okay. So due to this stable arrangement of electrons in valence cell of noble gas, each element of periodic table tends to achieve stable nearest noble gas configuration. Stable nearest noble gas configuration. Okay. So let us see chemical nature and electronic configuration of few metals and non-metals and noble gases. They have given in the table. Even in our textbook also they have given. So why? They always, if you take this, all the metals. So potassium, if you take, what is the valence electrons? Anybody? Potassium. 19 is the electronic configuration. Sorry, atomic number is 19. Can you tell me the electronic configuration, please? Potassium. I want to know. Potassium, please. 19. Speak, Ra. 19. 90 class you studied. 2n square. What is the formula for electron arrangement? Speak loudly. Learn 9th class remembering 2n square, Bohr's model. Remember or not? Chapter number 4. Bohr's model. Understanding? 2n square. So what is the electronic configuration? Speak loudly. 2, 8, yes.
8, 1.
8, 1. So what is the valence cell? K, L, M and N. So K, L, M, N. N cell is the valence cell. So it will lose 1 electron or gain electron, 7 electrons, which is easy. Loss of 1 electron is
Lose 1
easy.
electron.
Yeah, loss of 1 electron is easy. So it will lose and it will attain the nearest stable gas electronic configuration. 2, 8, 8. Which is the nearest stable electronic configuration? Check it, everybody. Yes. 2, 8, 8. Who is that? Nearest electronic configuration. What is the name? Argon. Okay. So by loss of 1 electron, potassium acquires the nearest electronic configuration of whose noble gas? Everybody. Argon. Understanding? Now, sodium by loss of 1 electron, it will acquires the nearest electronic configuration of whom? Neon. Understanding? Chlorine by gain of 1 electron, it will acquires the nearest electronic configuration of whom? 18. 17 become 18 now. By gaining 1, 2, 8, 8. Yeah. By nearest electronic configuration of whom?
Argon.
Argon. Understanding? So they will lose the electrons or they will gain the electrons or they will share the electrons. Only ultimately one reason. What is the reason, guys? To acquire the nearest electronic configuration of which gases?
Noble gases.
Noble gas.
So that is what you have to remember it. That is the ultimate target of every metal, every non-metal, to acquire the stability towards to the nearest inert gases. Please note it, inert gases, noble gases, all the unreactive gases, all are same. Everybody learn that inert gases. What is the gases name? Helium, except helium. Helium having how many cells, guys? Helium having how many cells? One cell.
Only one
Cell name.
cell.
Yeah, one cell. What is the cell name? K cell. Okay. That alone becomes stable in nature. Except helium. Remaining all the cells, how many electrons are there in valence cell? Valence cell, how many electrons are except helium?
8 electrons.
8 electrons. Okay. So what are the noble gases? Helium, neon, argon, krypton, xenon, and radon. Learn it. Helium, neon, argon, krypton, xenon, and radon. These are called as noble gases. You remember entire 10th class, you won't go behind krypton. Krypton is also very rarely only you will get it. 100, mostly the questions will come the nearest electronic configuration of argon. More than this, you never find. Very rarely only you will go to the krypton. But have a glance. Helium, neon, argon, krypton, xenon, and radon. Please learn this. These are called as what? Noble gases. Okay. You must need to know first one, lithium, sodium, potassium, rubidium, cesium, and francium. Alkali metals. Second one, beryllium, magnesium, calcium, strontium, and this is not required, barium. These are called as alkali earth metals. You can see here, alkali metals, alkali earth metals. Then 3 to 12, we used to call it as transition metals. Next, 30, this green color one, these all are called as post-transition metals. And here you are seeing the brown color one, these are called as what? See here, what is that? All of you, metalloids. Okay, and these colors, these are called as reactive non-metals. And last one we used to say noble gases, and this one we used to call as lanthanoids. From 57 to 72 lanthanoids, from 89 to 104 actinoids. And here you can see the colors, these unknown colors, unknown properties, still properties are under research. That is why the color is given. So why I am not mentioning this organism in noble gases, because properties are yet to be decided. So that's what this color, the properties, unknown properties, this is. These all are not required. Learn only alkali metals, hydrogen is not included anything in the periodic table. Hydrogen not belongs to alkali metals. Understand, guys? All of you? And doesn't mean that hydrogen is belongs to halogens also. It's not belongs to any kind of group or any kind of, it belongs to first period, but does not belongs to any group. That is what you have to remember. Okay, guys? So first group will start from where? Alkali metals will start from where? Hydrogen or lithium? It will start from lithium, sodium, potassium, rubidium. At least these 4 metals you learn. Okay. And same way, halogens means 4. Fluorine, chlorine, bromine, and iodine. These 4 you learn. Okay, guys. So this is what about the cause of chemical combination. Now, simply anybody can tell me 2 words. Why the chemical combination will take place? What is the reason? Anybody? Because to acquire the what? Single word you can say. What is the reason? Why chemical
To
reaction?
acquire stability.
To acquire the
Stability.
stability. Understanding? In order to acquire the nearest noble gas electronic configuration. That's all it is. All about what is electronic configuration. Now, if you take your textbook, they have given, all of you see that? They have given one tabular column of noble gases. Of course, if you want, you can write it. So noble gases, metals and non-metals. So let us all of you observe this one. You are all having tabular textbook. Am I right? So all of you follow that. So helium, neon, except helium. Helium alone having how much? Only one shell. What is the shell number? Everybody. K shell. That is why it's become stable in nature. Am I right or wrong? Next, neon. 10 electrons. 10 means what? 2, 8. So become stable. 8 electrons. Valence shell. Argon. 2, 8, 8. It is also become stable. Understanding? So 8 electrons in valence shell. Let me take krypton also. My meeting is going to end. Join back. So krypton, what is the electronic atomic number? Tell me. Krypton symbol. Capital KR. Krypton atomic number is 36. Can you tell me the elements, please? Loudly speak, everybody. 2, 8, 18, 8. This is the electronic configuration of krypton. So it is also valence electrons are 8. Become stable or not? Everybody, please respond. So all the noble gases, how many electrons in valence shell? Valence shell, how many electrons? 8 electrons.
8.
Except helium. Helium alone one shell. That cell itself is a what cell? That cell itself is the valence cell, K cell. Okay. Next, sodium 11.